Okay, 3 squared is 9. Any non-zero number to the 0 power is always equal to 1. This is tricky because you have to square the 4 first before you apply the negative. So you square the 4 to get 16, then you pop on the negative. So we have to take the 3 to the 0 power first to get 1, and then we pop on the negative. So this is negative 1. Because of the parentheses, remember anything to the 0 power is 1, so it doesn't matter if this is positive or negative. Once we take it to the 0 power, this is equal to 1. There's two things happening in the exponent. There's a negative and a 2. If we take care of the negative first, I'm going to invert this. So in other words, I'll have negative 6 over 5, and now this is to the positive 2. And when we square this negative is in here, it's getting squared away, it becomes positive. This will become 36, and this will become 25. Because this negative is in the parentheses, and this is an even exponent, this will square away and become positive, and we square the top and get 9, and square the bottom and get 4. There's two things happening in the exponent. One is the fact that we have a negative up here, so let me do that. We're going to invert this and just flip it upside down. Now that's to the positive 3. A negative is being multiplied out an odd number of times, so this negative will stick around. And then we do the top. 4 to the 3rd power is 64, and 3 to the 3rd power is 27. Okay, 3 to the negative 1 is 1 over 3. 4 to the negative 1 is 1 over 4. We're just inverting this because of the negative. And now we need a common denominator, which is 12. So this I have to multiply by 4, so I do that to the top and get 4. This I have to multiply by 3, so I do that to the top. 1 times 3 is 3. And finally, I keep the denominator once it's common, and I add the numerators. 4 plus 3 is 7. I'd reduce this if I can, but I can't, so we're done. Okay, here I'm going to leave this negative on the outside, and I'm going to take care of this negative first. So right now I have negative, and this will become negative 3 over 2 to the positive 3. Now this negative is being multiplied an odd number of times, so it remains negative. 3 to the 3rd power is 27, and 2 to the 3rd power is 8. And we still have this negative on the outside. Now these negatives will multiply together, and we'll get a positive 27 over 8. When your bases are the same and you're adding, you add, and you're multiplying, you add the exponents. And the reason for that, this is x times x times x times x. This is x times x times x, and so we have a total of 7 of them. This 3 and 5 are multiplying because they're not bases, they're coefficients. So when I multiply those, I get 15, and then we're going to have x to the 3 plus negative 4 is negative 1. So then what I'm going to do is I'll create a fraction. I'll move anything with a negative exponent to the other side of the fraction, and this will become 15 over x. And then there was more than one way to do that, but that's the way I did it. First thing I'm going to do is I'm going to multiply. Negative 2 times 3 is negative 6, and we're going to have x to the 4 plus negative 2 is positive 2. And then there's no simplification. That's our final answer. Whenever you're dividing and the bases are the same, you subtract your exponents. So this is going to be a 1 over x squared. And the way you can think of this is there's 5 x's on top. That's x to the 5th. And there's 7 on the bottom. 3, 4, 5, 6, 7. And then we just start canceling. So everything cancels out of the top. We get a 1, and we have an x squared on the bottom. It's easier not to do this and just to subtract our exponents. So I'm going to cancel. Well, this becomes a 2 and a 5. So now we have 2 over 5. And 8 minus 4 is 4. So we have x to the 4 on the bottom. There's two things in this exponent. One is a negative and the other is a 3. Here's what I'm going to do. I'm going to have a negative to an odd power. That's going to remain negative. And then I'm going to have 2 to the negative 3, x to the negative 6, y to the positive 9, and z to the negative 12. And then I'll create a fraction. This is a negative. This negative is just right there. And then everything with a negative exponent goes to the bottom of the fraction. So, and everything with a positive exponent stays on the top of the fraction. So on the top I've got y to the 9. On the bottom I have 2 to the positive 3, x to the positive 6, and z to the positive 12. And finally I've got to simplify that. This becomes an 8. So our final answer is negative. On the bottom we have 8, x to the 6, z to the 12, and on the top we have y to the 9. Okay, this negative, because that's an even exponent, that negative will get squared away, so it'll become positive. And then I bring this in. So I have a positive 2 to the negative 2, x to the negative 10, y to the positive 4, and z to the positive 6. So now I'll make a fraction, and anything with a negative exponent goes to the bottom. So I have y to the 4, z to the 6 on top, 2 to the 2, x to the 10 on the bottom. And finally we'll evaluate that, and that becomes a 4. And that's it. For number 18, this is an even exponent, so this is going to square away. And while I'm at this, I'm just going to cancel this. It becomes a 1 and a 2. So now when this squares away, when I bring this in, I'm going to have, up top, I'll have x to the negative 6, y to the 8, over 2 squared, which is 4, x to the negative 10, y to the positive 14. And then I'm going to move this up, and we're up top, we're going to have x to the 4, and on the bottom we're going to have 4 y to the 6, and we get y to the 6 because 14 minus 8 is 6, and we get x to the 4 because negative 6 plus 10 is 4, and this 4 just stayed here. For number 19, this is a negative inside of the parentheses, and this is even. So this will square away, and I'm going to end up with 2 to the 4, x to the negative 12, y to the negative 8, z to the 16. Then I'll make a fraction bar, and this will go down, and these will stay put. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. And when we move the x down, we get x to the 12 and y to the 8. Okay, there's two things happening. Here we have an odd exponent, and so this negative is going to get multiplied out an odd number of times, so it'll remain negative. So we have a negative, and we're going to have 2 to the negative 3, x to the positive 12, y to the negative 15, and z to the positive 6. So now I'll make a fraction bar. There's a negative in front of it from this, and then this will go down, and this will go down, and this and this will stay put. So we have x to the 12, z to the 6. We're going to have 2 to the 3, y to the 15. And finally, this is going to be 8. So we're going to have negative x to the 12, y to the, z to the 6 over 8, y to the 15. By combining like terms, this and this are like terms. 5 minus 6 is negative 1, but you don't write the 1. And this are like terms. Negative 1 plus 2 is positive 1, but again, we don't write the 1. Combining like terms, this, and this are like terms. Negative 1 plus 5 minus 4 is 0. So we don't write any of the x squareds. They just disappear. And then we have this and this. 3 minus 7 is negative 4x. We're going to multiply a positive and distribute it through. And that just doesn't change anything. Okay, now combining like terms, this and this are like terms, and those add up to 5x squared. This and this are like terms, and those add up to negative x. And this are like terms, and they add up to 0, and so they're not included in the answer. So that's the answer. Okay, here I'll take the positive and distribute it through, and that doesn't change anything. But then here I'll take the negative and distribute it through, and that'll flip the sign of everything here. Then combining like terms, this and this are like terms, and those combine to negative 3x squared. This and this are like terms, and those add up to 0, so they're not included in the answer. And this are like terms, and those add up to negative 4. Okay, here if I distribute a positive 1 here, we're just going to get rid of those parentheses. But if we take a negative and distribute it through, that flips the sign of everything. And then combining like terms. That and that are like terms. That adds up to a negative 1, but we don't write the 1. This and this are like terms, and those add up to 0. And this are like terms, and those add up to positive 1. To get rid of those parentheses, I'll distribute the positive 1, and we'll just have negative 5x squared plus 2x minus 3. And then I'll distribute the negative, and we'll get positive 8x squared plus 3x plus 3. Combining like terms, those add up to a positive 3x squared. These are like terms. Those add up to a positive 5x. And these are like terms, and those add up to 0, so they're not included in the answer. So that's just the answer. To find the slope, let's solve this for y. So I'm going to start by moving my 2x over, and we're going to get 3y is equal to negative 2x plus 3. And if you divide by 3, we're going to get y is equal to negative 2/3 x plus 1. So the slope is negative 2/3. It's the number in front of the x. Okay, to solve this one for y, we'll move this over, and we'll have negative 4y is equal to negative 6x plus 4. And then we'll divide by negative 4. And we're going to get y is equal to a positive 6 over 4, which is 3 over 2. So your slope is positive 3 over 2. These are opposites. One's positive, one's negative, and they're reciprocals. You flip them upside down. So opposite reciprocal slopes are perpendicular. For number 1, to solve this, we're going to move the 6x over, and we're going to have negative 2y is equal to negative 6x plus 8. And then we'll divide by negative 2. And we're going to get y is equal to a positive 3x minus 4. So the slope here is 3. This slope is already in slope-intercept form, so that slope is 3. These are the same, so these are parallel. I'm going to use the intercept method for this. If I cross out the y, x is negative 4. If I cross out the x, y is negative 4. There's no equal sign here, so this is a dashed line. And I'll put arrows on either side. Now, when I'm ready to shade, if I follow the x's, because this is positive, x's go left, right. Because of the greater, I'm going to be shading to this side of the line. Okay, If I had done the y's go up, down. Because this is positive, I would go up, which is the same side of this line. This is in slope-intercept form. My y-intercept is positive 1, and I'm rising 2 and running 3. There's no equal sign, so this is also a dashed line. We have to consider y because it's the only variable to the left, and this is positive, so we follow this. We go down. So we're going on this side of this line. So we're looking for stuff on this side of this line and this side of this line, which is this stuff right in here. And that's it. This is already in slope-intercept form. This is like a plus 0 over here. So our y-intercept is a 0. And then there's like a 1 in front of here. So we're rising 1 and running 1. There's an equal sign. So this is a solid line. So when I graph this, it's going to look like this. And arrows on either side. This is a vertical line through x is negative 2. And it's a solid line because there's an equal sign here. Now, this is an or, not an and, so I got to graph everything. So when I graph this, the y, I'm graphing on the upper side of this line, which is this side of this line. So I'm going to be shading everything on this side of this line. Okay, and then for this, greater than or equal to 2 is everything on this side of this line. So then I have to include all of this stuff. And the only stuff that doesn't get shaded is this little portion right here. I'm going to use substitution for this. If I get rid of my x's, I have to bring them to 6. If I get rid of my y's, I have to bring them to 12. I'm going to get rid of my x's. So that means I'm going to multiply this by 3 and this one by negative 2. So this will give me 6x plus 9y equals negative 9. And here we have negative 6x minus 8y is equal to 0. When I add them up, the x's go away. This adds up to 1y, and this adds up to negative 9. Then I can take that and plug it back in here, 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 or here. I'm going to plug it back in here because that looks like the easiest to me. So I have 3x plus 4y is equal to 0. So x is going to be equal to 12. So when you make your ordered pair, you have to put your x first and then your y. You can always take these values and plug it back in to see if you get equalities to check your answer. Because I'm given a choice and x is solved for, I'm going to use substitution. I'm going to take this and plug this stuff in here. So this will give me 2x minus 3y is equal to 16. And x is 2y plus 9. So now I'll distribute this. I'm going to combine like terms. That becomes y. And I'll move this over. And I have 16 minus 18 is negative 2. I could technically plug this into either one, but this is always the easiest because it's solved for x. So here, I'll have x is equal to 2y plus 9, and y is negative 2. So this is negative 4 plus 9, or 5. So when you write your ordered pair, your x always comes first, and then your y. To find f of negative 3, I'm going to plug negative 3 in for this. So we're going to have 4 times x minus 3, and x is negative 3. So this will give us a negative 12 minus 3, or negative 15. To find g of negative 2, I'm going to plug in, here's my g function, negative 2 for x here. So I have 2 times x squared minus 3 times x minus 1, and x is negative 2. So this square turns into a 4, which is an 8. And then this is plus 6, and then minus 1. 14 minus 1 is 13. Here we have a rectangle, so I'm going to do this, and I'll say this is my width and length. So x equals the width, and y equals the length. Now, the length is 5 feet more than twice the width. So the length, which is y, is 5 feet more than twice the width. The perimeter is 64. That means the perimeter is twice the sum of these two sides. Because the sum of this is halfway around, we got to do 2 times that because we got to go the other side too. So using substitution, I'm going to substitute for y. I'll plug this right in here. So this stuff is going to go in here. You know, instead of distributing this 2, I'm going to divide each side by 2. So I divide this side by 2 and this side by 2. And then I'm going to combine like terms in here. So I have 3x plus 5 is equal to 32. What I did is I divided each side by 2. And that canceled. And so we have the 3x plus 5 here is 32 here. So I'll move this over, and we'll get 3x is equal to 27, and then dividing by 3, we get x is equal to 9. To find y, we'll go 2x plus 5. (18 plus 5 is 23. So the dimensions are this is in feet, so it's 9 feet by 23 feet. Okay, this is a mixture problem. So I'm going to have the number of liters times the percent purity equals the number of pure liters. We have a 50% solution, a 25%, and a mixture that is 40%. So the easy stuff is this. All right, we'll call this x and y. In other words, x equals number of liters of the 50% solution, and y is the number of liters of the 25% solution. There are a total of 100 liters, so that goes there. We're multiplying to get this. So the product of these is 0.5x. The product of these is 0.25y. And the product of these is 100 times 0.4. So our two equations comes from the sum of these is this, and the sum of these is this. Well, this, if we solve for either variable, like if we solve for x, we get x is equal to 100 minus y. And now we can use substitution to plug that in right there. So we're going to have 0.5 times 100 minus y plus 0.25y is equal to 100 times 0.4 is 40. We'll distribute this and we'll get 50 minus 0.5y plus 0.25y is equal to 40. This 0.50 minus 0.25, that's a negative 0.25. And when I move this over, I have 40 minus 50, which is negative 10. Bringing this here, we'll get y is equal to 40. That's what we're actually after, because we're after the 25% solution. If we wanted the 50% solution, we'd have to go x is 100 minus that, which would have been 60. But this answers the question, so I'll stop there. So we have, there are 40 liters of the 25% solution. That's it.